IT can be extremely complicated. And if you're an architect, how do you put these things together, even as a user? So one of the problems with computing and software is it's complex, inherently complicated, and you can make it idiot-proof, simple. Don't make me think. Systems design. You can think of design thinking. All that's great functionalities, but inherently being as complicated as it is, you can say it's way more complicated than rocket science or brain surgery, as they keep saying. So if something as uh, complicated as in casual conversation, we may say something like it's as complicated as brain surgery or it's rocket science. But software development in IT is even more complicated. Now, some of the components, just to break this down into any system that is there, even if it's your smartphone, your Fitbit, or most devices, digital devices that we have, are getting even more complicated and reaching organic level proportions. I mean, you can take any living creature, and amoeba, even the single cell organisms are probably far more complicated than anything here. But as we improve and bring in AI integration of the internet, it's getting complicated. So just let's look at some of the components that go into a solution that you get. For example, if you order something on a e-commerce site and that food reaches you, or if you order a cab and that cab comes to you and you're able to get in and go to where you need to go, and there's a map. So some of the components that go into the solutions could have one, more, or all of these things. So let's look at it in serial number. The first is a server. There has to be a backend. There has to be somewhere where the data resides. It could be within your country. It could be outside your country. It could be anywhere in the world. So those are servers. Servers are also evolving in various ways. There are server farms. Some of the servers are so large and vast, the way Google and Microsoft and AWS use. You even it's using up so much power that even keeping it in on an uh, iceberg or in the Antarctic is a cost saving because the power consumption will be reduced. So servers can be extremely complicated in themselves. Then next comes users. What decides the server and the size and space is how many users, how many are going to hit the server at any given time, all the devices, whether laptops, mobiles, from all over the world or whatever region during the time of day, evenings, overnight. So how many users uh, do you share, not share? So the second factor is number of users overall. It would be just a few thousands or it could be millions. Next is connectivity. Is it safe? Um, can you trust it? How is it connected? Is it wired or wireless? So various aspects of does it actually connect the input output between the users and the servers is the next factor. Four is broadband. So what do you mean by broadband is also that uh, when you do text data back and forth, it uses very little bandwidth. Just storage requirements, speed requirements are much lower as opposed to audio. Audio will be much higher, and video could be substantially higher than that. So giving you a ratio on 100, if data requires 1 in 100 in terms of capacity, audio might require 8 uh, in terms of capacity. With 8 out of 100, you'll be able to transmit high quality audio back and forth. On the same scale, you'll then require 91 for video. So that's the order of magnitude in terms of what you would need for the speed broadband storage. So those are factors that come up there. Then going on to five, peripherals. So some of the peripherals are the sensors, actuators that plug in and out of your device, whether your smartphone or your laptop, your local device, on-premises equipment, whatever that may be, fax machines or speakers, microphones, are all components that allow digital capture of data into the system and then from out of that system back to the way you want it. So peripherals, devices, Internet of Things could broadly be put into these set of things that go into getting data in and out of those devices. Then software has at least three, four layers, what we call the operating system, iOS, Linux, Windows, Android. So these are operating systems at a base level. Above that, you have software like Microsoft Office, apps, uh, open source software. So all these become applications, standard applications which work on these. A further layer is what you may have created. So the spreadsheet could be a layer two, but then what you have inside the spreadsheet is yours. That's personal data or office data. So software gets into those levels of data. So software should differentiate between the data and the software at a level six. At a level seven, we have devices. So devices such as card readers, barcode, RFID autologgers, which are uh, similar to peripherals at one level, but they might not be discrete. They may have to be used, maybe even built into your devices as well. A key factor, which should really be nine power. Nine is the power. So this is a factor if you whether you are connected to the grid, uh, do you have solar power, where's the power going to come from, and how long is it going to last? So this is a key factor. So the size of any device is dependent on the battery. Battery contributes substantially to the power, weight, size, cost of the unit. So power and how the power is going to be given to all these devices, it's dependent on electricity is another factor there. So, which leads us to the eventual, blind four, five blind men looking at a elephant and saying, "What is it?" So, information is very different for each person, for education, for entertainment, for doing business, for uh, getting your work done, self-improvement. So, information can fall into a huge variety of uh, uh, it means different things to different people at different times. So eventually, all this comes down and around to know how and data, analytics, insights, and skill sets that eventually result in monetary activity or non monetary activity, tangible, intangible, and it's all linked to the information that rides on all of this.